Hi, my name is Sireesha Gutti, and I go to Paul Laurence Dunbar High School in Lexington, Kentucky in the United States. So my project aimed to understand why men have an increased incidence and mortality rate for leukemia. Leukemia is a blood cancer, and men are almost 65% more likely to be diagnosed with leukemia and almost 78% more likely to die of leukemia. My project focused primarily on AML, or acute myeloid leukemia. So in order to understand this difference in sexes, I focused on the sex chromosomes, and I performed a statistical analysis on two different databases. One of the databases that I used was GEPIA, which I used to determine the difference in expression between AML and normal, and the other database that I used was UALCAN to determine the difference in expression between males and females. So what I found was that there were 7,964 genes that were expressed differently between AML and normal. Of those genes, none of them were on a Y chromosome, but there were many of these genes that were on an X chromosome. Of the genes that were on the X chromosome, 5 of these genes had a significant differential expression between males and females. These genes were ARSD, MBNL3, TCEAL3, VCX3A, and FMR1NB. Of these 5 genes, 2 of these genes answered my question of why men might have an increased rate of leukemia, which were MBNL3 and FMR1NB. MBNL3 is overexpressed in AML and could possibly serve as a possible tumor promoter, while FMR1NB was not expressed at all in AML and could possibly serve as a possible tumor suppressor. Each of these genes could be targeted in sex-specific treatments to help lower leukemia rates.